Namaskar. Hi students. I am Ejaz Sheikh from KKWAG Arts, Commerce, Science, Computer Science College, Kakasaheb Nagar. Let us see the FIBSA Computer Science Electronics Paper 2nd, Chapter number 3rd, Combinational Circuits. Using a reference book, Digital Fundamentals by Floyd, Digital Electronics by R.P. Jain, and Digital Principles and Applications by Malvino. Combinational logic circuits. A combinational logic circuit is one in which the present state of the combinations of the logic inputs decide the output. The term combinational logic circuit means the combining the two or more logic gates to form a required function where the output at a given time depends only on input. That is, a combinational logic circuit is a digital circuit whose output depends on present state input conditions only. The combinational logic circuits are mainly made from logic gates. Figure shows the block diagram of combinational logic circuit which has n number of inputs and m number of outputs. The required output data is obtained from this process by transforming the binary information given at input. Now, the classification of combinational logic circuits. The combinational logic circuit can be classified as arithmetic or logical functions, for example, adder, subtractor, comparators, etc. Then data transmissions, for example, multiplexers, demultiplexers, encoders, decoders, and code converters like binary, BCD, 7 segment, etc. The characteristics of combinational logic circuit. The output of combinational logic circuits at any instant of time depends on the level present at the input terminal. The combinational circuits do not use any memory. The previous state of the input does not have any effect on the present state of the circuit. A combinational circuits can have an n bit or n number of inputs and m number of outputs. Half adder. Half adder is a combinational logic circuit with two inputs and two outputs. Half adder circuit is designed to add two single bit binary numbers A and B, which gives output in the form of carry and sum. Here a figure shows the block diagram, truth table and circuit logic circuits of half adder. Then full adder. The full adder is also a combinational logic circuit which performs the addition of 3 bits at a time. Digital adder or full adder. The block diagram and the truth tables are also shown in a figure. As shown in a block diagram, the full adder has 3 inputs A, B and carry in, while 2 outputs sum and carry. Here we can design a logic diagram of full adder using OR gate and AND gate. Then decoders. Decoder is a combinational circuit that have n input and 2 maximum or outputs, that is 2 raised to n outputs. The decoder is identical to the demultiplexer without any data inputs. It performs the operation which are exactly opposite to the encoders. Here we can see the block diagram and truth table of 2 to 4 line decoder. As shown in block diagram, the 2 to 4 line decoder has 2 inputs while 4 outputs. The logic diagram of 2 to 4 line decoder. Then encoder. Encoder is a combinational logic circuit with designs to perform the inverse operation of decoder. An encoder has n number of inputs while m number of outputs. The encoder produces an m-bit binary codes corresponding to the digital input numbers. The encoder accepts n inputs digit words and convert it into m-bit another digital words. The priority encoder. It is a special type of encoder in which the priority is given to the inputs. So if the more than one input is given, then according to the priority, the inputs are selected and output will be generated or created at the output of encoder. Figure shows the block diagram of 4 to 2 line encoder which has 4 inputs and 2 outputs. The logic diagram of 4 to 2 line encoder. Thank you very much to listening me and watching my video. Stay home, stay safe. Have a nice day.